So the three types of safety: personal safety, general lab safety, and today it's about the scroll saw. Right up here, scroll saw. Scroll saw means scrolls are like waving cuts, intricate turns. This is a machine that lets you do that. Hot wire styrofoam cutter. Hot wire styrofoam cutter. And then we're also going to talk about how you would use a hand drill, a battery-powered hand drill, like this, for drilling holes. Because the chassis of our vehicle, which will be the next thing that we do together as a group when I come back to work with you, has to be cut. You're going to see this as a big long strip of wood, and you're all going to have to cut your own base out of it. So you're going to be measuring this to 9 inches. We're going to show you how to mark and make a line, and then this will get cross-cut up here on the scroll saw. We'll all do that together one day. God bless you. Christina, right? God bless you, Christina. And then everybody will also be cutting out their foam block, which is 2 by 2 by 2.5 inches thick, on the hot wire styrofoam cutter. And then you'll be marking it on the rear side so that you can drill a 3/4 inch hole. Okay? So you notice the first thing I did when I came in the room, because I knew I was going to work today, was check my 10 points of safety, put on my safety glasses. Right now I'm in the safe zone, so I should be the only one in the safe zone, right? And I'm just going to sit in a chair here so that I can face you and everybody can see me. But I would normally be doing what I'm doing over the tabletop. And if I was doing just marking a piece of material, all of that would take place at your desk, right? We only come up here to use a piece of equipment in the safe zone. But if we're going to be working on our vehicle, hot gluing things, drawing, sketching, designing, all of that will take place back in your seat. All right? Okay. So what I have here is a square tool. I know it looks like a T, but they call it a square tool because it makes right angles, square angles. And to cut out the back of the chassis, I'm going to need to mark this piece of material. So we always ask that before you make a cut of any kind or perform an operation on a piece of material, that it's measured first. So again, I would be doing this on top of a desktop, okay? This is just for you to be able to see it. So I set this thing up so I can put it across the material. I can slide it back and forth, and it always keeps a square measure. And I've marked it out to 2 inches thick. You ever seen one of these pencils before?
Yeah.
Have you? Why is it shaped like a rectangle? It's nice and skinny so it can fit down inside somewhere to make a mark. And its shape keeps it from rolling off the table. Right? Anyhow, they're also nice and big and thick because as you're writing on material that's not paper, it's going to wear away a lot more graphite. All right, so I've got this marked at 2 inches this way. The material is already 2 inches thick. So I've marked it to 2 and 2. Now I just need to measure out to 2.5. So I have clear lines where I'm going to make a cut. And so I don't get confused, I'm going to put an X through that piece of material I don't want. This is the piece I do want here. Now what I know about the hot wire cutter is that as you cut, it's going to be removing some of the foam. So you can always cut a little bit bigger than you need to the first time, and then come back and get it closer, right? Measure twice, cut once, and always cut off maybe a little bit more than you need so that you can work it down to the exact size later. Okay. Pull the stool way out of the safe zone. My sleeves are rolled up, my long hair's tied back. So long, isn't it? And the way the scroll saw works is this blade, which is a little bit longer than what you see because the blade itself is going down into the machine a little bit, this blade goes up and down right? And it just performs a motion faster than you could probably do it with a handsaw and more accurately. The teeth are very small and the teeth point down. The teeth point down so that as they go down and cut into the material, when the blade comes back up, it won't pull the block up with it. Does that make sense? If the teeth were aiming upward, it would be lifting the material up every time you're making a cut. This piece up here, what do you think this is for? I'm smacking my finger against there.
So you don't like put your hand in the objects.
Yeah, so you can't put your finger too close to the blade. We always want our fingers to be at least 4 inches away from anything that's performing an operation. And this thing will be called the foot. Kind of because it's shaped like a foot here, but it's also referred to as a guard or a fence. A lot of most machines will have some type of a guard or something that protects you from the material, or a fence that is a guide that you can ride a piece of material against as you make a cut. All right, well, I gotta be able to move this foot up and down because this piece of foam, for example, isn't going to be able to go underneath that foot. It's just like when you raise and lower a bicycle seat, you have to loosen that little screw first, and it's called a set screw. So I'm gonna take this knob, loosen it. Now I can bring this up and down. So I could bring this up to the height. Let's see if it goes under there, yeah? Just about 2 inches. Not too tight on top of there, but resting on top. And so as you can see, the scroll saw will be able to cut through 2-inch thick foam. What it won't cut through is a piece of wood that's 2 inches thick. It's just not that powerful. But it works great on materials such as cardboard and really thin strips of plywood. We never will put anything in there really any thicker than this. Or thin pieces of dowel rod. Dowel rod. So dowel rod is the term for a piece of material that's been spun and dwindled down into this circular material. Do you know that, you know a 2x4? You ever seen a 2x4? This isn't a 2x4, but this is probably a 2x2. Okay? And this is really easy for them to make in a factory because it's just one pass with the saw this way and another pass with the saw this way to make these sides. But how do you think they get a round shape like this made inside of a factory? Yeah, they're actually spinning. The piece of material is spinning like this, and there's a big blade here. It's kind of like it's chewing away at corn on the cob as it spins, and it just keeps making it thinner and thinner and thinner. It actually costs more money to make this rod than it does to make this piece of wood. Even though this is way smaller, this one would cost more money to make. Anyway. A board like this that's 3/4 inches thick, wood, would be much too big to put inside this machine. All right, so the thin stuff and the thin plywood. So I'm going to demonstrate making the cut here on the foam. We can also do the same exact thing on the hot wire cutter. We'll look at that next. Have my glasses on, I check the set screw, the machine's plugged in, and here's the power button down here. With a little light so we can see. What's that? I have a variable speed adjustment here. We can go faster or slower. I keep it somewhere right around the middle. And there is a yellow button that pulls out of here. And if you don't have this, you can't start the machine. The button won't turn on. All right. And if you're wondering what this little hole is down here, as sawdust falls into the throat plate of the machine, it collects down at the bottom. That's something that you could vacuum out later. Okay. The tabletop itself sits flat and perpendicular to the blade. There's another adjustment down here, and I can actually turn this knob if I want to cut the piece of material on an angle to make an angled cut. But I'm going to leave it perpendicular. And then when I go up and the blade is should be sitting in the middle where I want to cut, and I have my hands on the left and right sides of the material. I never want to put my hands or my thumbs in line with the blade as I push through. Okay? All right. I'm the only one in the safe zone. Turn the machine on. If for some reason it sounded really funny or was making a weird noise or something didn't look right, just turn it off. Mr. Anderson, if you have a little gut feeling at all that something's not right, doesn't sound right, just check with me, okay? All right. I went in halfway through the material right now, and as long as I pull straight back out, it's okay to pull back if I'm right in that same line where I just cut on a piece of foam. But for the most part, once you get into a cut, you want to keep going. And if you're not in the right spot, well, that's why you always cut a little bigger the first time, and then you can come back and cut closer. Go all the way through, remove the material. One more cut to make here. Turn the machine off before I walk away. And now I have all this dust on top. I don't blow it off because then it could get all over the floor, right? Make things slippery. So I would bring over the shop vacuum. We have one up in the corner up there, and we have another one back here. And clean up after yourself. If there's a line here and there's a few people working, you don't have to vacuum the machine after each time. So I've got the block cut out here, and while I'm on it, I'll show you how you would be cutting out your base plate. Actually, don't need that one. Same thing. Measure down the 9 inches. If you put this across the material, you know you're going to have a perfectly straight line here. Mark it. Lower the foot. Right above the height of the work. No one in the safety zone. Left hand, right hand, push through. Any scraps that you have shouldn't end up on the table like this. They're going to go into a scrap box, and they'll be located underneath the machines. Okay? That way we don't end up with piles of stuff around here. People can make a habit of leaving their drawing pencil here or setting their safety glasses, and then they leave a piece of wood here, and then somebody else comes up and they leave a drill nearby, and then all of a sudden we have this really dangerous pile of stuff. Nothing else needs to be up here. Everything will be at your seats. Okay, you ready for the hot wire cutter? Have you seen this thing before?
No.
Right. Yes? A few of you? So the hot wire cutter just uses this piece of nichrome wire, and as current goes through this transformer back here from 110 volts, it brings it down to a voltage that when passing through this wire creates heat. Okay? You can't tell that this is on right now because it doesn't like glow red. It doesn't have a button on it that lights up. It's just you have to always assume that it's on when you come up to the machine. Okay? It's going to be your responsibility to turn it off and on yourself, but always turn the hot wire cutter off before you walk away from it. All right? So, we can test it by putting a piece of foam up to the wire. We can see how it cuts right through there. Just trying to make a person who's about to eat something. Let's see. Isn't that neat? But it definitely melts some of the foam right on the line that you're trying to travel across. So again, if you draw something out, don't cut right on the line, cut a little bit next to it, because it's always going to keep getting smaller as you keep working on it. Because then you might sand the piece down. Scraps go down in the scrap box. So the hot wire styrofoam cutter, you're only supposed to keep the material flat on the table. You would never be holding it up in the air and using this thing here. Okay? Another neat thing you can do is make one shape like this and then turn it on its side and slice it many times. I saw someone take a block about this size before and turn it into 200 butterflies. Yeah. Real thin slices, all made out of this one piece of material. When you think of it like that, sometimes you look at something small and you go, I don't even want to put that in the scrap box and throw it away because it could be used again. And that's the purpose of the scrap box instead of the trash can, is we can always try to repurpose and recycle the materials that we haven't used. Let's say I want to make some other types of cuts here. I'll draw a shape. I want to make this circle. And if I want to put it, I would not just place the circle right in the middle of an object and trace it, because then I'm going to waste all the material around it. I'd want to take this circle and place it maybe right here and only take up that amount of material that I need. Okay? And this is good for making nice curved cuts as well. I'll stand to the side so you can see. Would you like to stand up and come a little bit closer so you can see it? Let's see if we just, right about there is good. Okay. You asked about the air conditioner. This is actually an air filter. And one of you saw me put my hand near there and then pull myself away when I realized I could feel it was warm. If you bump into this, and you are not allowed to touch this wire intentionally, but I want you to know that if you bumped into it real fast, it's not going to light your hand on fire, but it would burn you. So what we ask that you do is wear these leather gloves when you use the hot wire cutter. Wear these leather gloves, and we're going to keep them up in a blue basket up there by the front table. Okay. Let me just show you this cut real quick.
Could it cut through the gloves?
No, it would not cut through the gloves, but it could burn them if you kept them on the hot wire. But the idea is it would burn the gloves and not your hand. Can you see okay? All right. Again, I should be in front of this machine, but I want you all to be able to see just what it looks like as it's cutting here.
Oh, that's so satisfying.
And you see, if I were to cut right on that line and leave it there, it just keeps burning and the hole gets bigger. See that?
Oh, yeah.
So you want to keep moving and stay a little bit outside your line, because you can always get closer a second time.
Oh, definitely. Nope, stay.
I'll finish this cut, turn it off. All right, can we go? Drill. Performs the same type of operation as this drill press here. The drill press you will use with us possibly to drill the hole out in the back of your foam block. We may also be using the hand drill, but you're not going to use the drill press until you get up into 7th or 8th grade. Okay? The teachers will be the only people using this machine. A hand drill, however, a battery-powered hand drill, is one that you can use. When you see a drill bit like this that has some people call them twists around the side of it, they're actually called flutes. You know that this is going to be something that removes material. And the only part that actually does the cutting is the very tip of the blade. All right. You may also see people put a driver in here. It's called a driver when it has a star point at the end or a flathead for putting in screws. Have you ever seen that before? And either way, both of them can come out by taking these two different parts of the chuck and turning them in opposite directions from each other. And as I do this, these little teeth that go inside that tighten around the bit and then open and tighten comes loose. I can take the bit out. I can put the bit back in, spin, 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 turn these in opposite directions, and it's inside. It has variable speeds around here. The higher the number, the faster it will spin. So higher numbers would spin faster for a drill bit. A lower number we might use if we're driving a screw, because it takes more power to screw a screw in through a thick piece of material. It has a forward and a reverse button. That just changes the polarity on the motor to make it go forward or reverse. And then it has a battery, 9.6 volts. Some of these drills go up to 24 volts. Pull this button back, release the battery, and we should always make sure before we leave class each period that any batteries we used get put back in their battery chargers, and then we put fresh batteries back into the drill for the next class. Okay? All right. They're pretty lightweight too. This is a vise. I know the word vise has many definitions. In this case, it's something like a clamp that can tighten something. You could probably put a quarter in here and with just your pinky spin this lever around and bend a quarter in half. And it's really great for holding on to material that you want to drill through. Because what we will never do is hold something with our bare hands and try to drill a hole through it. It will either have to be clamped inside of a vise. Let's spin this around so you can see it. Now I could drill into that material very easily, and I have both hands free to do that. And you could actually use this vise yourself up here and perform a cutting operation. Otherwise, we bought these personal bench vices that you can all use right here. Everybody see that? All right, it's a little one that you could take back to your tabletop and use over there. But you're going to have to treat your tabletop like a safe zone. So if you are working on your vise here, you have to make sure that no one else is within 3 feet around you. And in fact, when we're in lab, we might even maybe set up another table with a couple of these that you can go over and use. Tighten it up. If I wanted to take this and remove it from the table, there's a C-clamp down here. Everybody see that? Everybody? The C-clamp down here. Pull this off. You don't want to drop this on your foot. This would be one of the reasons why we wouldn't wear open-toed shoes or sandals in class during lab. Did we do the safety lesson yet? They haven't seen that yet. You'll see what we're talking about later. I'm going to do this with my back to you. I'll show this once for the camera here, and then I'll turn around sideways. Button should be in on the left-hand side, in on the right-hand side so that the drill bit is spinning clockwise. Mark the material first so I know where I want to drill a hole. Forgot to do that. Start slow. Yeah, and foam is a really soft material. It's really easy to work with, and that's one of the reasons we use it on your first project. And it's forgiving, and it's inexpensive, and it's easy. If you mess something up with foam, we have more of it. Christina?
Does the direction the drill thing is spinning affect the cut?
Yeah, it's only shaped to cut clockwise. It won't cut counterclockwise. I've seen people try to make these holes bigger by taking their drill bit, and when they're drilling, going sideways and this way and that way. We just go straight in and out. You could do that with a piece of foam because it's soft, but if you do that with another piece of material, it's going to be bad for the drill bit, and the drill bit could get caught. So for all of our purposes, straight in and out. There's a variety of drill bits here in this case, and we'll have access to these in the toolbox. They make bits that are called spade bits when you want to drill a hole that's bigger than the actual shaft that you're putting into the drill. And these flatheads or Phillips heads are called drivers. The reason I put this hole in here in the first place is because I wanted to show you what you would do if you wanted to cut a big circle out inside of here. Because if I'm on the hot wire styrofoam cutter and I want to cut a circle out from the inside, I can't get in there without cutting the outside. Does that make sense? So I want to cut this shape out. So I gave myself a little pilot hole first that I know the hot wire will fit through. I'm going to test to make sure that the hot wire cutter is off. All right. Push down on this aperture. And you can see it loosens the blade. Okay, I'll turn it back on. Now I can make this inside cut. Now if you're in a hurry, you might get impatient and you push too fast, you could snap the wire. We have more wire, but just try not to push too hard on it. Let the wire do the cutting for you. Let it do its work. And you're right, it is really like satisfying to cut through foam. It gives you a neat, immediate feeling of accomplishment to see what you've done. Get my inside cut. Okay. Pass those around. I know the frayed stuff on the ends looks like cotton candy. You don't want to eat it. Another tool is the junior hacksaw. The junior hacksaw. I remember when I was little, I saw my father using one of these, and he was cutting a big, heavy metal pipe in the basement, except he had a larger hacksaw like this. And I had seen other saw blades, and usually saw blades that I saw before, saw blades I saw, had really big teeth. What can you say about the teeth on these blades? They're really small. You can almost barely see them. In fact, the smaller the teeth, the harder the material that you'll be cutting through. So a saw with these really small teeth could cut through foam very easily and wood, but it would also cut through a piece of metal. You can use these on your styrofoam. So I have a piece of material here. What was this called again? Dowel rod. Whether it's a dowel rod, a piece of plywood, or a piece of styrofoam, we would never cut these in our lap or hold them up in the air and cut them. In fact, we wouldn't even hold them down to the table with our hand and cut them. They will always, for cutting with this blade, always put whatever you're working on inside this vise or this bench vise up here. If I wanted to cut just a little bit off, I could turn it up like this, like you're saying, and make the cut. Make the cut from the side here. But But wherever I'm going to do it, if I'm going to do it like that, or I'm going to pull it up this way and do it here, you would always want to do the cutting as close to the vise itself as possible. This can work. I'm not going to do this sitting down. I'd be standing up, mark the material, place the saw blade in onto a spot, and make a slow pull. A slow pull for that first one, just so I get a groove there. And then I could start to saw a little bit faster. Use the whole blade. Whether you do it horizontally or vertically. Where you can't do it is out here, because that doesn't work. It's moving all over the place. It's not steady. It's not stable. Another thing I don't want to do with the vise is leave any material sticking out and protruding from the table surface, because somebody could walk by and get poked in their stomach. Okay? So your hot glue gun does have to get plugged into some form of power, and the glue comes out really hot. You know, I've stuck my finger before in candle wax, and that, you know, it's kind of neat. It's not the same as hot glue. Hot glue is much hotter than candle wax. So sometimes if you put hot glue directly onto styrofoam, has anybody had this problem before?
No.
It just starts melting through the styrofoam.
Could you do it?
I haven't even plugged the hot glue gun in yet, so it takes a few minutes to warm up. So resist the urge or the temptation to do that, okay? You also it'll also melt if you touch the hot glue gun tip to the styrofoam. So often what I'll see people do is they'll put hot glue onto their base first here, and then they'll put the foam onto that, as opposed to the other way around. When I'm using a hot glue gun, it has to be plugged into some power outlet, and our intention is for you to be able to do this from your seats. So you'll either have a power strip at your tabletop that you can plug into, or there may be an overhead power strip that hangs down from a cord, because the last thing we want is you plugging into a wall and having this cord sticking out from across the edge of the wall for somebody to trip into, right? No hot gluing can occur up here at the workbench. It would all occur back over at your seat, okay? This is the high melt glue gun. It takes the large glue slugs. As you pull the trigger, it just keeps feeding it. So it's really cool you're getting to start to use all this stuff now. And your first time using this or any of these pieces of equipment, we're going to be doing it with you. We're all going to be, me and Mrs. Monahan, we're going to be standing at the machine, watching you turn it on the first time, seeing that you know how to use it and turn it off properly. And only after that, and after passing a safety test, so the demonstration of the machine and the safety test, will you have permission to use that in lab. And then even for the first few lab periods, you're not going to be allowed to grab any tool or use any machine unless you ask us first, so we can check and see that you're properly marking your material and that you're ready to use it. And then you're going to get to a point, though, where I could see maybe even by 8th grade, you're able to use everything in the lab autonomously. Wouldn't that be great? Yeah, I have a lot of college students who have never used any equipment like this before, and they have to learn a lot of stuff really fast. I really think it's really cool that you're all starting to learn to be respectful toward this equipment and put the proper safety instruction in now, and you'll get a chance to practice it in a nice new lab environment. Just really awesome. Hot glue guns or glue gunning will also occur on a cutting mat like these. Have we shown these yet? Yeah, so these you can put down at your tabletop. It's okay to get glue on them. We want to try to keep the whiteboard surfaces as clean as possible, as long as possible. And you can keep them protected using these. You can also unroll a piece of the big brown paper on the big brown paper roll. Okay? You can help yourself to that too and put that down on the table. But if we use the big brown paper, we could probably leave that and roll it up and save it for another class. Okay? And keep using that stuff over and over. PVC, polyvinyl chloride. Polyvinyl chloride's pretty cool because we can make PVC pipes like this. We wouldn't want to put a PVC pipe into a fire or melt it because it would give off polyvinyl chloride gas, which is pretty toxic. So, but that's why you'll never see this pipe above ground either, because the ultraviolet rays of the sun can damage PVC pipe just like it can damage our skin, right? Ultraviolet rays. And that could leach into a water supply. So all of these pipes are always used underground. They're never exposed to sunlight. We can use them in the room though because there's no natural sun. This is a pipe cutter. I know it looks kind of like a C-clamp, but it has a little wheel here. And if we could put this over top of the pipe.
Wait, is that thing sticking out sharp?
This?
Yeah.
No, it's for removing burrs. I'll show you what a burr is in a second. Get that wheel in there tight, give it a spin, tighten it up, give it a spin, tighten it up, spin.
Do we keep spinning until it can't move?
No saw needed, nothing sharp. What's that? Did you see this part already? Oh, we did this during our walkthrough yesterday, right? Yeah, I know, but we haven't captured it on video yet, so I wanted to make sure everybody who watches the video gets to see it.
We can see the bird.
Yeah, so this comes out of the back of the pipe cutter. And you put this into the pipe here and twist it and remove any sharp edges or burrs that are sticking out of the piece of material. All right, so before cleanup, or when cleanup time starts, all work stops. The first thing you do is return things that you were using. And the second thing we do is bring the vacuum cleaners over and the dustpans, and everybody pitches in around the entire lab. All right, everybody. That was really nice job today. We got to go over the hot wire styrofoam cutter. Hold on, pal. The scroll saw and the vise, and using the vise with the hand drills.